Compounds X, Y, Z and W are constitutional isomers of each other, and they are aromatic compounds, and they have the molecular formula C8H10. We are to deduce the structure of W based on the clues given for X, Y and Z, and these are the NMR spectrum characteristics of these three compounds. So go ahead and pause the screen, solve it or try to solve it, and start it when you're ready. So the clues here given are spectroscopy clues, especially proton NMR and C13 NMR. C8H10 is the formula, which means you can deduce the double bond equivalence. So if you have 8 carbons, that means for a saturated compound you're going to have 2 times 8 plus 2, 18 hydrogens, but you have only 10 hydrogens, which means you have 8 hydrogens divided by 2, which is going to be 4 double bond equivalents. That means you have one benzene ring based on what you see in the molecular formula, and that's what they already told you as well, but still it is always good to solve the double bond equivalents or know the double bond equivalents. So you have a benzene ring, and clue 1 for compound X tells you that the proton NMR spectrum exhibits 2 upfield signals and a multiplet near 7 ppm with an I, which is integration of 5. So this clearly tells you that you have an ethyl group. How do I know that there is an ethyl group? There are 2 upfield. So when you look at the the NMR spectrum of an aromatic compound, or any compound for that matter, right? If you have a signal that is around 7, that means that corresponds to the aromatic part of the molecule. And if you have signals at the low ppm value, which is called as the upfield region, that means you have aliphatic chains in the molecule. Okay, so when the integration for this molecule is 5, that means this is going to be the structure of the compound, which is X, because you have 5 hydrogens that are aromatic hydrogens, I equals 5, and you have 2 signals corresponding to this ethyl group, and we know how NMR works for an ethyl group. This hydrogen is going to be a triplet because you have 2 hydrogens next to it, and this hydrogen is going to be a quartet. Okay, so you will see a quartet and a triplet, and usually you will see this hydrogen appearing around 2.1 ppm, and this could be somewhere around 0.9 to 1.5 ppm. So that is the structure of X. If you look at Y, they say that it has 4 signals in the C13 NMR. Okay, 4 distinct signals in the C13 NMR. So which means we have to draw structures that will have 4 distinct carbons. So if you have the metaxylene, then you will have 1, 2, 3, 4. 1, 2, 3, 4. Because this molecule is symmetric, you will have 4 signals. So that is the structure of Y. And if you look at Z, it has only 3 signals. So we have to look for a structure that is going to have only 3 distinct carbons in the molecule. So this is going to be a lot more symmetric than Y. So you can try different possible structures, and you will find out that 1, 2, 3. That paraxylene is going to be the isomer with only 3 distinct carbons. Okay, 1, 2 and 3. These are the same. Therefore, this is going to be Z. That leaves you with only one more possibility for writing an isomeric structure, which is going to be the metaxylene. Okay, so 1, 2, 3, 4. 1, 2, 3, 4 and 5. So this is the distinct structure you can write other than these 3 structures. So this is going to be the structure of W.